now, so we're going to apply the math operations. Class, tell me a basic math operation. Addition. What else? Subtraction. Okay, pay attention. Super important. This is a dot, which refers to which math operation? This is very important because this is not fog. Fog is an open circle, and this does not mean f times g. This is called a composite function, which means you take g and put it into f. Okay? So make sure you know the difference. And then number 4, what math operation? Division. Okay. So if you have your 2 different colors, super helpful. Or where do we get our f's and g's from? Well, we already did that in the previous problem. This says f plus g. This one says f minus g. This one says f times g. And this one says f divided by g. So this one says plus, minus, times, and divided by. So f is just 2x plus 1 plus our g of x, which is 4x squared minus 1. Now, go ahead and look at your neighbor's paper. Kind of give them a tisk-tisk, like, bad on you, if they didn't draw the parentheses around it. Class, why do you think those parentheses are important? It separates them, and when you get to other math operations such as subtraction, does that make sense? Then you're going to have to distribute. So, question, do I need the parentheses here? No, because there's no number in front, there's no exponent, and there's no minus signs. So it's just 2x plus 1. Do I need the parentheses over here? No, I don't. Which ones are like terms?
1 and 1.
Okay, so I don't think you would make that mistake, but some students do, like, oh, Mr. Ings, does that mean I put a plus 1 here because it's opposite, and I put a plus 1 over here? You only do opposites when you're going across an equal sign. On one side of the equation, you just add or subtract. So positive 1 and negative 1 equals? 0. So I'm left with 4x squared plus 2x. Okay, now it tells us to find its domain. F and G got married, and in marriage, they go somewhere, and then they have kids. And that's you. So pretend you get in trouble in this class, and I'll ask you the question. Which parent will make you get in trouble the most? And you're thinking to yourself, you know what? Mr. Ring, don't tell my mom, because she's the most strict parent. Everyone say MRD. I think we learned that on last week. What does MRD stand for? Most restrictive domain. And I kind of do a play on the words. I'm saying who is the most strict parent. Now, in this case, in this family, both yellow and pink parent, they're kind of lenient, right? They tell their kids they can do whatever they want. You can go anywhere to the negatives, you can go anywhere to the positives, you can go anywhere you want. So who's the most strict? No one. So I'm just looking at both of their domains, and I'm looking for the most restrictive, the most strict parent. Alright, let's try another math operation. What are we doing now? Minus. What's f of x? Tell me. G of x. Uh-oh, what do we got to do? Yeah, you can think of this as 2 words. You can say inverse or you can distribute a negative 1. I don't need the parentheses here, but over here I do. Class negative 1 times 4x squared.
Negative 4x.
Negative 1 times negative 1. And then I'm just going to combine like terms. Which ones are like terms? You are correct, too. So negative 4x squared plus 2x plus 2. Okay. Look at their parents now. Which one's most restrictive? They're still the same. Sounds silly I'm asking that question, but when it becomes more difficult, then you got to think about that, right? So your answer is negative infinity to positive infinity. And think about it for your parents. If one parent grew up kind of strict, like think of grandma, if she's really strict, then guess what? Then their daughter or son's going to be really strict. So you're entering that really strict relationship and you get married, it's kind of like, well, one person's kind of strict, one's kind of lenient. And parents already know which parent you like to turn to, because hopefully because you love them and not because they're going to give you what you want. What's my yellow? Pink. And the math operation. Multiplication. That's a dot. The reason why I do not like using the word FOIL, because it doesn't work after just binomials times binomials. Draw my box. Outside of my box, we're going to multiply. Boys, 2x times 4x squared. Cubed. Boys. Girls.
4x.
And girls. So after you multiply these, you will get ax cubed. These are not like terms, right? So 4x squared minus 2x minus 1. I do want to point out now, sorry that was blurry, that they are written in descending order. Everyone say descending order? Descending order, or down order, is by the exponent. X to the third, x to the second, x to the first, x to the 0 power. Okay? Put your finger on the most restrictive domain. Right there. Pay attention. Pay attention now. Number 4. What math operation? Oh, your best friend came back. Rational function. 2x plus 1, 4x squared minus 1. What? Sorry. Okay, so I'm looking at this problem, and why I think it's kind of tricky or laughing is you got to start thinking of all the things we've learned about rational functions. Tell your partner some things you might know. Ready, set, go. Kevin, tell me something. Ooh. Set the denominator not equal to 0. Okay, Kevin, harder question. Why do you do that? Kevin? I'll give you a hint. The answer is somewhere on this page. You are correct. To find the domain of a rational function, you are setting the denominator not equal to 0. So now I'm going to add 1. 4x squared is not equal to 1. And then I'm going to, what do I do next? Square root, divide by 4. You're actually going this way in PEMDAS when you're solving. You're going to divide by 4. So you're left with x squared is not equal to 1/4. Now what? Yeah. You see how exponents and radicals, which is opposites, are last? So now you do the square root of both sides. X is not equal to... Good. Positive and negative. The square root of 1, which is? Two numbers that multiply to be 1. 1. And square root of 4 is? 2. So, what is my domain in set builder notation? You can pick, in the set of x, you can pick every x value, right? In the element of x, you can pick all real numbers, but what are the two numbers we can't pick? You cannot pick 1/2 and -1/2. Okay, so this is the domain. We kind of split the answer. Normally we have like that big red box. Let's draw a red box and then we can just put it back in. But we didn't divide here. Talk to your partner. 10 seconds. How would you simplify this? All of your math power energy right here. See if you got it. All the years past, students always miss this one right here. Tell your partner what you think. Yen. For an A on the quiz, which I'm not going to give you, but you would get an A on the quiz if you get this question right, because you know it. What do you need to do in this problem? It tells you to divide. There's your end. You want to cross off something. Raise your hand if you thought about crossing off something. That is in the right direction. You're going to factor. Raise your hand if you knew that. Oh. 2x plus 1. If you made that one a 0x, 4x squared. Math ghosts in the closet. Things are moving in there. That's scary. Must be that student from last year who didn't start for their quiz. Because they're stuck in the closet. What is it? When you factor. 2x and 2x plus 1. Ooh. I'm not going to spend my time showing you the x box. Just factor it. I'm going to put a parentheses around this because a lot of students get stuck on that part too. Because we have a whole when you cancel, right? So we have a whole at 2x plus 1. And now you're just left with 1 divided by 2x minus 1. That's the answer. When you divide f by g of x, you get 1 over 2x minus 1. And in the domain, you can pick every number except for positive 1/2 and negative 1/2. So here we in the last problem, you can't go back to the most restrictive domain. Do you know why? Because you're thinking these numbers, but we already know this is saying, okay, you could pick every single number when you add, subtract, or multiply. But if I picked negative 1/2, this will become 0. Something divided by 0 is undefined. Does that make sense? So here we applied the math operations to our composite functions.